What I have here in front of me is a selection of different common types of meters you might see in industry, in homes, automotive, just about everywhere. Now, all these meters are going to have different uses and different ratings. So there's different ways these things are used. Now, if I start with one meter right here, pretty common meter, I use this one because it can actually connect to a computer and go on screen. But this has got a rating right here, voltage rating, of no more than 1,000 volts. Anything above 1,000 volts will cause this meter to fail. If I want to read electrical current with this meter, okay, this current will pass through the meter, in this terminal, out the common. So you have to interrupt the circuit, no more than 10 amps. Now the fuses that are in the back of the meter, those fuses right there, there's two of them, one for 10 amps, one for 1 amp. Those fuses are high energy specialized fuses. If you ever pop the fuse in the meter, do not replace it with a standard fuse. They have to be high energy fuses that can withstand the short circuit currents at that point you're measuring. So they are specialty. So you have to replace some specialized fuses. You're not going to find them in hardware stores. You'll only find those fuses in supply houses. So they're very specialized. Now this specific meter right there will read a lot. You have AC voltage, DC voltage, frequency, reads diodes, ohms, continuity, capacitance, temperature, microamps, milliamps, and amps. Very useful type of meter, but this meter, because of its functions, is more often used right there on a test bench rather than in the field. Now, a lot of people prefer what are called analog meters. The analog meter works just as well. It has a needle that deflects back and forth. The mirror behind the needle makes it more accurate to see where the meter's measuring. But this meter only reads things like DC voltage, DC amps, ohms, and AC voltage. The deflection on the meter gets down to preference right there, be digital or analog. This one's analog. It all gets down to preference. You only have two terminals for inputs here. This one is category 2. It's 1,000 volts AC, 250 milliamps max. So the rating's right on there. If you exceed those ratings, this meter can explode. So the ratings on the meter are pretty straightforward and clear. We take this common meter. It's a clamp-on amp meter. This is an amp probe. There's all kinds of these out there. Right here, the current says maximum 400 amps, 600 volts, Cat 3. Well, this little clamp right here can read no more than 400 amps. If you go above 400 amps, one, the wire's not going to fit, and two, if you do get it to fit, it'll probably cause this meter to actually catch fire and burn. It will not explode, but it'll catch fire and burn. Now, that's 600 volts, so 600 volts at 400 amps. Now, the category, one meter was category 3, the other one's category 2, this one's category 3. The category identifies the location of use. You could use this meter, and it will not explode from random transient voltages. Transient voltages occur many times a day in a facility. It's up to 300 times easily. And that high voltage spike could exceed the 600 volts, exceed the 400 amps. So the category is a safety protection telling you where you can safely use the meters. We get into that. Now down here, the voltage rating on this meter is 600 volts maximum, Cat 3. Two terminals here for voltage. Indicator dial here dials into what I want to measure. So kind of a simple meter right there, very popular, but they do have a small screen, hard to read. Here's another version right there of that amp probe meter. This one itself right there is another clamp-on amp meter. This one has got a maximum of 2,000 amps. Category 3, 600 volts. So as long as I'm 600 volts and less, I can measure up to 2,000 amps of this meter. And I can use it in category 3 locations. Now, this meter is also identified as what's called true RMS. Most meters are not true RMS. They will only read a sinusoidal sine wave. This meter will read all types of sine waves. What that means to you is, if you're measuring a normal power circuit, any meter will work. But if you're downstream of protected electronics, solid state equipment, drives, welders, power conversion equipment of any kind, if you do not have true RMS, you will get false readings. And I will get more into that later on. Down here you have the voltage ratings. 600 volts, Cat 3. So no more than 600 volts. If you go over 600 volts, the meter will explode. Cat 3 again is the location to use the meter. Now, common meter you see in industry is this guy. Most all your electricians and maintenance will be using these things. They're very simple. They're inexpensive. They fit in your pocket. They read ohms, continuity, amps, volts, and they turn off. Test leads are attached. You don't have to worry about testing and changing them. All you got to do is turn it on. If you want to measure current, you run the current wire through these little probes right here, and it measures the magnetic field of the current. So a very useful tool. Inexpensive, fits in your pocket, you drop it, they tend to bounce. Very useful tool. So there's different types of meters available everywhere. Let's go with this meter. This is very popular for many people. This is what's called a tester or an indicator. Okay, these things have the nickname Widowmaker, and there's a reason for this. Now, this has got a rating right here. This one is rated from 90 to 1000 volts AC. It's category 4 up to 1000 volts. So as long as it's 1000 volts and less, I could use it in category 4 locations. Make that kind of simple. Now, the rating right here, 50 right there, or 90 to 1000 volts, that's based on a brand new battery. Problem with these are, if you drop them right up here in the tip, they break. If the battery gets weak, it doesn't read within its rating. So in other words, these need to be tested before and after every single use to verify it works. If that battery wears down, it might only read between 150 and 700 volts. There's no way to identify what the voltage rating that turns this on. So again, these have to be tested before and after to verify they work. But they are good tools to use. This meter right here has been used in industry for a long time. It is a rotation tester. It tests rotation of magnetic fields in three-phase circuits. It tells me right there if you have a normal ABC rotation, which is clockwise, a counterclockwise rotation of CBA. It tells us if we lost a phase right there or a leg in the buildings. So very useful tools these are. This one specifically has a test button to turn it on and off, and this could actually be used to test the rotation in motors before you hook the motor up. Very useful tool. We'll get into how these used. Now, this has got no category rating on it, so it's only used as category 1. So at different categories, we have different ratings. Now, we start looking at all these different types of meters. I grab a pair of test leads. The test leads we use in a meter, these test leads are going to have ratings on the test leads. It's going to have a voltage rating and a category rating. Now, it's kind of important that we use a test lead that's rated for the voltage we're going to measure and the category we're going to be used. So most of these will say 1000 volts Cat 3 or 1000 volts Cat 4. Now, test leads themselves have these little finger guards here on the end. This is a safety feature. Finger guards. If they don't have finger guards, don't use them. Easy to slip. Now, the problem with test leads right there is these things will wear out, and they do wear out. Though we got to learn how to test the test leads. I'm going to take this meter right here, and I'm going to go ahead and turn it on and turn it to ohms. Now, the test leads themselves when I plug this meter in and touch the test leads together, what I'm getting is right here, 0.7 ohms. I'm getting a resistance, 0.6. This is the resistance of the actual test leads, the wires. Now, we can do a couple things to fix this. We can wiggle the test leads and pull the test leads in and out. This normally reduces the resistance because they do get oxidation build up on those test leads. In this case, it didn't. Well, the problem here is this number right there we're seeing, this 0.7 on the test leads, 0.6, 0.7, this is going to affect every single measurement we take. So test leads are disposable. It is recommended that you remove and throw away and replace the test leads when they reach 0.5 ohms or less. Now, to find out which test leads are bad and which test leads are good is a simple process. We leave the meter set to ohms, right there in ohms, leave one of the test leads plug in, and we put the test lead inside of the opposite terminal. So this test lead is actually reading 0.3 ohms. So this test lead would still be good. Now, we put in the other test lead, the black test lead. Put in the common, it reads OL, and I go ahead and take my measurement of the volts ohms. Okay, this test lead is reading 0.3 ohms. Altogether, we got about 0.6 to 0.7 ohms. But when these test leads add together and get right there to 0.5 ohms or higher, this is when they should be replaced. Now, finally on these, the category ratings. The category ratings on this meter are simple. Right here, where the volts leads plug in, it says Cat 3 1000 volts. Cat 3 1000. This meter right here tells us right here on the top 1000 amp, 100 amps, 1000 volts, Cat 3, 600 volts, Cat 4. Well, the category rating really doesn't have anything to do with voltage. Right over here we got another reading. It says 2000 amps, 600 volts, Cat 3, 600 volts, Cat 4. Well, the category ratings, what they are is a rating where you can safely use the meter without seeing the meter explode. So this is what's called locations of use. There are 4 locations you can use. For example, a category 4 meter, right here, Cat 4, this is used anywhere indoors, outdoors, anywhere that might have transient voltages. So it could be used in the building, out of the building, as long as it's 600 volts and less. If I go above 600 volts, this is only considered Cat 3. So in a facility, this Cat 4 meter could be used anywhere. But now the Cat 3 meters are a little bit different. We take this meter right here labeled Cat 3, right there, Cat 3 600 volts. Cat 3 meters are only designed to be used indoors only, downstream of the service equipment. So this is general use anywhere in the building except for service entrance. So you would not use Cat 3 on a switch gear or main panel coming in. That'd be a Cat 4 location. This is everywhere else throughout the building. Now we get down into these types of meters, something like this, which reads right down here Cat 2. The category 2 meters are only designed to be used on branch circuits. So this is going to be lighting and receptacle use. So it's very limited in where they're used. So the categories of meters. Meter 101, guys. Be safe. Meter safety. Here we have what are going to be ratings on meters. If I have a 225 amp 480 volt circuit breaker, that power is coming in from the top, power is going out to the bottom. This is feeding a load somewhere within your building. It's in a cabinet. If I go to take a measurement with this meter, I can measure right there across any two phases, top, bottom of the meter, any two phases at one time, and take a measurement. Now the difference here is we've got different types of meters. If I use a 300 volt meter right here to measure 480 volts, this meter is going to explode. The meter can only withstand 300 volts, and putting 480 volts across the leads, you have an arc flash within the meter. That's one surefire way to make a meter explode. So we're always going to use a meter rated greater than the circuit you're going to measure. So the 600 volt meter would be the meter to use. But we also take a current measurement, and again we have two meters. One meter is rated for 200 amps, the other meter is rated for 400 amps. The circuit is rated 225 amps. Well, we don't know what the circuit's drawn. So let's say the circuit actually draws around 220 amps. If we use a 200 amp meter and have 220 amps passing through that meter doesn't explode, but it does catch fire and burn. It will destroy the meter. It's only rated for the 200 amps. So again, we use the larger meter, 400 amp meter for the 225 amp circuit. We always use a meter rated larger than the circuit we're going to measure. Meter 101, pretty simple. Now, meters are also rated in categories. A category is going to identify the location of use where you can safely use a meter without the meter worrying about the meter just randomly exploding for no apparent reason. Okay, now why the meter explodes, I get to that next. But these meters break down into categories. You have what's called Category 4, Category 3, Category 2, and Category 1. So these categories identify the location of use. Example, a Category 4 meter can be used anywhere. Right here from the point of service at the utility connection, anywhere throughout the plant, anywhere throughout the building, indoors or out. It's a very well protected meter. A Category 3 meter is only designed to be used indoors. You use the Category 3 meter downstream of the service equipment. So you don't use Cat 3 in service equipment. That's a Cat 4 location. Category 2 meters are limited to branch circuits. You have lights and receptacles. So branch circuits. So this is typically a residential meter. Category 1 meters are used on protected electronics and test bench work. They are downstream from protected electronics. So test bench work, solid state electronics, you're going to go fix the copy machine, fix the printer. These are all categories. So they all show locations of use. But the problem here is meters will randomly explode for no apparent reason. And what causes the meter to explode is what are called transient voltages. In all reality, if we measure this electrical sine wave on an oscilloscope, for a 120 volt circuit, the top of that wave is going to be 170 volts. What we actually see with a meter is called a root mean square or an RMS voltage, which is the 120. This is an average voltage. But now the problem here is you get what are called transient voltages. You get lightning strikes, lightning hits, let's say within 6 blocks from you, half a mile away. Doesn't have to hit a power line, all it has to do is hit close by. You could very easily have a transient going through your electrical system in your building in excess of 100,000 volts. Well, if you're taking a reading with a meter that's only rated for 1,000 volts or 600 volts, that meter explodes. Okay, not only you have transients from lightning, but you have power system switching from utility companies. You've probably seen all these big switching yards that are around towns and around industrial areas. Okay, those big switching yards are used all the time. All day long, these guys will open up and close air switches. If they need more power in one area and less in the other, they reroute it. And every time they open and close a switch, they have a transient voltage of about 2,000 volts. Most people have got power electronics in their facility. Okay, you got solid state equipment, you have drives, you have welders, you got all kinds of equipment today with a built-in power supply. These circuits right there create what are called harmonic frequencies. These power supplies take current only in a pulse, and that pulse happens at the peak of the sine waves. This creates electrical harmonics, but it also charges and discharges the large capacitors in the system. And as those capacitors charge and discharge, it creates a transient of about 2,000 volts. Well, under any one of these conditions, you got a 600 volt meter or a 1,000 volt meter, you measure a transient, the meter has a chance of exploding. Well, the next problem here is these transients occur in population centers anywhere between 200 to 300 times a day. This is the reason for categories. Now, categories on meters have been around since 1987. This is when they first started acknowledging the transient threat and the transient hazards. So meters have been identified with categories. If you find a meter that is not marked with a category at the test leads, then that meter was manufactured before 1987, and it is considered as a Category 1 meter. So a lot of the old meters that people like to use, especially the old analog Simpsons, those are actually only rated today as Category 1. So meter categories, guys, this is a safety rating.